All right, let's just jump right in. No long introductions today because honestly, we've got something super urgent to talk about. We're looking at a phenomenon that I like to call the cold open mistake. It's this sneaky little trap that quietly sabotages the grades of even the most well-prepared students every single exam season. Seriously, you do not want to fall for this. So here is a totally generic student answer we see all the time. 9 out of 10 students fall right into this exact trap when writing about systems or conversions. They'll write something like, memory and storage are the exact same thing, and you convert binary by just adding the numbers. Okay, why is this a fatal flaw? Because Cambridge examiners absolutely relentlessly penalize vague everyday language. In computer science, precision is literally everything. If you aren't using the exact terminology, you're dropping marks, even if you kind of vaguely understand the concept. But hey, don't worry, we're going to fix this mistake right now before you even have a chance to make it.
So how exactly do we fix this? Well, we follow a highly disciplined path to full marks. Instead of just guessing, you've got to rebuild your foundational knowledge using what we call the 4-prompt method. Whenever you're looking at any concept, verbally ask yourself, what is it? How does it work? Where is it used? And most importantly, why is it used? This framework completely forces you out of that vague terminology habit. You'll stop saying fluffy things like it saves data, and you'll actually start using the precise technical terms that examiners are actively hunting for on their grading rubrics.
Let's actually clarify that fatal flaw from our cold open. The distinction here is super precise. Memory, that is temporary data retention. Think of your RAM completely losing its contents the second the power turns off. Storage, on the other hand, is permanent data retention, like a hard drive holding onto your files long term. If a scenario asks you about saving a user's work and you just broadly say memory, you're getting a 0. Yep, a 0. Using precise technical terms instead of generic labels is exactly how you secure those top-tier marks.
Now, this need for total technical precision, it builds even further when we zoom out to computer networks. Put simply, routers are basically the traffic cops. They direct your data where it needs to go. Switches act as connection points for devices sitting within a single network. And servers, they provide the shared resources that everyone needs to access. Sounds straightforward, right? But just naming them isn't enough. You really need to understand how these components actually operate across totally different geographical scales.
The really crucial point here is how real-world contexts completely change your technical requirements. Like a personal area network, or PAN, operates within about 10 meters. Think about syncing your phone to your Bluetooth headphones. But if your exam scenario mentions an office or a school building, you absolutely must specify a local area network, a LAN. And for global connectivity, like the internet itself, we are talking about a wide area network, a WAN. The examiner-specific scenario dictates the exact terminology you have to deploy. You can't just mix and match.
And hey, speaking of examiner scenarios, here is another classic wrong turn. I call this mark scheme surgery. Validation checks the reasonableness of data, like making sure a month entered is actually between 1 and 12. Verification, though, simply ensures data has been copied or entered correctly without typos. Think of typing a new password twice to confirm it. Examiners heavily penalize students who mix up these two concepts in scenario-based responses. You've got to lock these definitions down tight.
When it comes to tackling complex hardware, it requires what we call the 3-layer mastery arc. Just think about a simple user request traveling through the CPU. It uses the data bus to carry the actual information, the address bus to figure out where the heck it's going, and the control bus to manage all the timing and signals. Visualizing it almost like a physical, real-world highway system makes these super abstract concepts tangible and way easier to remember.
So let's break down exactly how you actually master those layers. You always start at layer 1, getting a basic understanding in everyday language. Just wrapping your head around the concept. Then you move to layer 2, where you start layering on that technical vocabulary, like swapping out a basic word like wires for the correct term buses. Finally, you reach layer 3, the exam explanation. This is the sweet spot where you shape your technical ideas into the structured, sequential responses that perfectly meet those specific mark scheme requirements.
To bridge that raw technical knowledge with practical application, you really need a quick check guide. And there's a golden rule here regarding common mistakes. Never, ever state an advantage without providing a reason. I mean it. If you just write down, "it is faster," you won't get the mark. 0. You always have to justify why a specific choice is better in the exact context of the question they gave you.
Let's quickly run through the ultimate checklist to counter the exact mistakes we saw back in our opening hook. First, avoid vague wording. Second, order the mechanism logically from start to finish. Please don't jump around.
Third, like we just said, never state advantages without reasons. Next up, separate your description, what a thing actually is, from your explanation of how it works. And most importantly, maintain contextual specificity. If the exam asks about a hospital database, your answer must talk about patients, not just some generic data.
Now, when you apply this discipline path to the World Wide Web and browsers, sequence is everything. Seriously, you have to order a sequence logically. Start by prioritizing the core mechanism before you even touch on the consequence. For example, you want to explain how the browser actually requests the web page using HTTP long before you talk about the page rendering on the screen. It's a chain reaction. Sequence is everything.
But you might be wondering, how do you actually know how much detail to give? Well, that brings us to command word awareness, which is an absolutely crucial exam-taking concept. If a question asks you to state, it requires a simple, single point. Literally, do not write a whole paragraph. But if the prompt uses words like explain or evaluate, well, that is a massive neon sign signaling that you must provide detailed mechanics and reasoning. Your depth of answer must perfectly match the command word and the specific scenario nouns they've provided.
All right, let's test this out in real time with a 10-second interactive challenge. I want you to spot the fatal errors in this exam answer before the clock runs out. Ready? Here it is. The packet is sent, it is fast, and uses hardware. Look closely at that wording. Okay, time's up. Did you spot it? It's missing absolutely all the specific process steps. Plus, the wording fast and uses hardware is completely vague. It ignores the command depth entirely. You'd get crushed on the mark scheme for that.
So how do we fix an answer like that? By following a structured solution path. When you're explaining a process like packet switching, diagnosing the exact requirement and sequencing the explanation step by step beats a generic fluffy response every single time. You would explain the data being broken down into packets, getting given headers and IP addresses, being sent out across different routes, and finally being reassembled at the destination. That step-by-step flow is exactly the mastery path the examiner wants to see.
To get to that elite level of mastery across the entire syllabus, you need a seriously robust system. Enter the 3-pass revision cycle. Pass 1, you completely secure those precise definitions. Pass 2, you rehearse worked diagrams to truly understand the underlying mechanics. And Pass 3, you practice applying all of that to adaptable real-world scenarios. It is basically a foolproof loop for retaining high-level technical knowledge so you don't blank on test day.
Which brings us to our final and probably most provocative thought of this whole explainer. Have you just memorized the textbook, or can you now think exactly like the examiner? Look, passing is about memory. Excelling is about discipline and structure. If this explainer helped things finally click into place for you, make absolutely sure to subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCSE, so you can consistently excel in your Cambridge examinations. Let us know down below what topic you want us to decode next, and keep learning with focus.